We are moving to question number 10 now. This is an important one. In a YDSE, bichromatic light. Bichromatic means what? Two wavelengths, right? Usually we use monochromatic. This is bichromatic light. It's a typical question. All right. Bichromatic light of wavelength 400 nanometers and 560 nanometers are used. The distance between the slits is 0.1 millimeter. Distance between the slits is given 0.1 millimeter. And distance between the plane of the slits, this is the plane of the slits, right? And the screen is 1 meter. Okay, that is also given. Calculate the minimum distance between two successive regions of complete darkness. I'll tell you, look at this. So what are the possibilities here? Look at this. We have two lights being used, right? Both the lights will produce their own independent interference patterns. All right. For example, if I keep it like this is lambda 1, wavelength lambda 1. This is wavelength lambda 2. All right. So on the screen, there will be two interference patterns. Why? There are two sources, right? Each one will have its own interference pattern. And those interference pattern will merge on the screen. So what are the possibilities? Bright band of first light may fall on bright band of second one. So on the screen, there can be a location where bright of first light falls on bright of second one. Bright of first one falls on dark of second one. Dark of first may fall on bright of second one. Dark of first may fall on dark of second one. So that actually leaves with 4 types of bands on the screen, 4 possibilities. Usually we have what? Usually we have what? Only bright and dark, bright, dark, bright, dark, bright, dark, bright, dark. But there are 2 such patterns and they are overlapping. Am I correct? On the screen, they are overlapping. So what are the possibilities then? Bright band of first light falls on bright band of second light. Okay. There will be some locations where bright of first light falls on bright of second. That will be super bright. Understood? And then bright of first falls on dark of second. Then dark of first falls on bright of second. Dark of first falls on dark of second. This is called super dark. All right. So these two won't be discussed at all. We won't need them. We will look at the extreme cases only. What are the extreme cases? Look at this. Bright of bright. Bright of first one plus bright of second one. This is called super bright or absolute brightness. Understood? Absolute brightness. That will be super bright now. Got it. Now dark of first falls on dark of second. That will be absolute darkness. We will consider these two cases only. Absolute brightness and absolute darkness. This question is about what? Can you read the last part? Can you read the last part? Calculate the minimum distance between successive regions of complete darkness. It's about complete darkness. It must be this case then, right? Correct. So I'm choosing my case here. This is about, the question is about absolute darkness. Keep it in mind, absolute darkness, which means what? Dark of first falls on dark of second. Dark of first falls on dark of second means what? Distance to both of them must be the same. Am I correct? If they overlap, what does it mean? They should fall at the same location, right? Correct. See, darkness of, I'll tell you. So this is how you write it. Distance to the mth dark band of first light should be same as distance to the nth dark band of second light. Distance to the mth dark band of first light. Imagine this is the distance to the mth dark band of first light. Okay. Distance from center to mth dark band. Mth dark band, some number. All right. So this is the distance to the nth dark band of second light. If they are the same, that means they are overlapping, right? Correct. They are merging, right? Imagine, what do I want? I want super brightness. Super darkness, right? Super darkness means what? Dark bands should coincide. Correct. They coincide means what? Distances to them must be the same. Correct. So distance to the mth dark band should be same as distance to the nth dark band. Got it? Let me do it. So what is the distance to mth dark band? Do you remember this? 2m minus 1 into, do you remember the distance to the nth dark band? 2n minus 1 into lambda d by 2d. Don't do it now, I'll give you time. 2m minus 1 into lambda 1 d divided by 2d is equal to, tell me, what about the right side? 2n minus 1 into, tell me, lambda 2 divided by 2d. Same setup. So capital D will be the same, small d will be the same. Correct. So I can cut the terms here. Capital D gets cut here. 2D gets cut here. That is leaving me with 2m minus 1 by 2n minus 1. 2n minus 1 comes to this side. Lambda 1 goes to the other side. Lambda 2 divided by lambda 1. What is lambda 2? It is given 560 by into 10 raised to minus 9 by, tell me what, 400 into 10 power minus 9. This and this are cut. Cut this with this 780. That is 7. Cut this with 80. It is 5. So what I got is 2m minus 1 by 2n minus 1 is equal to 7 by 5. What is the next ratio? 7 into 2, 14. 5 into 2, 10. 14 by 10. Ratio still remains the same, right? 7 into 2, 14. 5 into 2, 10. Then next is what? 7 into 3, 21. 5 into 3, 15. Next is what? It goes on like this. Understood? Understood. So I got the ratio 2m minus 1 by 2n minus 1 as 7 by 5. I'll take one more fraction like this, 14 by 10. One more like this, 21 by 15. Next is 28 by 20. Next is 35 by 25. Understood? It goes on like that. I'll tell you. I'm finding m and n now. I'm finding m and n. I'll tell you. Look at this. First, I'm going to put m value. Put some random number. You have to do that intuitively. You have to put some random value for m so that the result is 7. Can you tell me what that number is? 2 into what minus 1 is 7? 4, right? Correct. Or you can take 2m minus 1 is equal to 7. 2m minus 1 is equal to 7. 2m will be equal to 8. M will be equal to 4. Understood? So, or you can do a calculation, mind calculation. It is m is equal to 4, right? And what about n then? You can put n. N is equal to what? You put 2 into 3, 6. 2 into 3, 6. 6 minus 1 is 5. So, n is equal to 3. So, this is where the first absolute brightness is. First absolute darkness is. Where is that location? Fourth dark band of first light or third dark band of second light. Fourth dark band of first light or third dark band of second light. I'm not done yet. I'll do one more part. What about this one? This ratio won't be taken. This ratio won't be taken. Why? Because the difference with 1 can never result in an even number, right? Or try putting something. Try putting 8 here. 2 into 8, 16. 16 minus 1 is 15. Correct. Or put 7. 2 into 7, 14. 14 minus 1 is 13. 14 you can't get. Understood? When you take the difference with 1, that will never end up in a no even number, right? So that ratio is not taken. What about the next ratio now? Put 21 by 15, right? Put some random number for m so that this is 21. 2 into 11 is 22. 22 minus 1 is 21. Spot on, right? So you can write, you can say like m value is, second case, m value is 11. Then tell me about n value. 2 into 8 is 16, right? Correct. 2 into 8 is 16. 16 minus 1, 15. So n is equal to 8. So I got my second location, right? This is what? So first absolute darkness is where? First absolute darkness is at fourth dark band of first light or third dark band of second light. Okay. Then second absolute darkness is where? 11th dark band of first light or 8th dark band of second light. Understood? Now in the second stage, we will find the distances to them and subtract. Why should we subtract? Because the question asks you to what? Find the distance between those successive darknesses. Got it? So you have to find the distance to this. How will you find it? You will use this formula. xmdc equal to 2m minus 1 into lambda 1d by 2d. Got it? So you will get the first location. Use the second number, you will get the second location. Then take the difference, you will get the final answer. Understood this? We'll do the second part now. All of you understood this? So I'll quickly revise this. Now we have bichromatic light instead of monochromatic this time. Bichromatic means there are two wavelengths here, right? Okay, so there will be independent patterns by lambda 1 and lambda 2, and they are overlapping on the screen. Okay, that leaves us with four possibilities. Bright plus bright, bright of first light plus bright of second light, bright of first light plus dark of second light, dark of first light plus bright of second light, dark of first light plus dark of second light. Okay, bright plus bright is called absolute brightness. Dark plus dark is called absolute darkness. This question is about absolute darkness. Absolute darkness means what? Darknesses should merge, right? So distance to the dark band of first light should be same as distance to the dark band of second light. Then only they can merge, right? Okay, they should be at the same location, right? Both the dark bands should be at the same location. Then that will be a super darkness location, right? Okay, so distance to the nth dark band of first light is equal to distance to the nth dark band of second light. You put 2m minus 1 into lambda 1d by 2d. This is the equation for it. We have done a couple of questions on this, right? It's equal to 2n minus 1 to lambda 2 divided by 2d. Cut 2d's out and capital D's out. You are getting 2m minus 1 by 2n minus 1 is equal to lambda 2 by lambda 1. What is lambda 2 by lambda 1? 560 into 10 power minus 9 given in the question. 400 into 10 power minus 9, that will be 7 by 5. So 2m minus 1 by 2n minus 1 is 7 by 5. Next ratio is 14 by 10. Next is 21 by 15. It goes on like this, right? So I'm taking the first location. This is the 7 by 5 is my first ratio, right? So I put m value as 4. 2 into 4 minus 1. That will be 7, right? N value should be what? 3. So 2 into 3, 6. 6 minus 1, 5. Got it? So m is equal to 4. N is equal to 3. That is the location of first absolute brightness. Sorry, absolute darkness. Got it? Where is the second location? This ratio cannot be taken. Why? Because this is difference with 1. That will never ever give you 14, right? It's an even number, right? So try taking the next one, 21 by 15. What is it now? So m value must be 11. N value must be 8. So 11th dark band of first light falls on 8th dark band of second light. Now I'm going to find the distances to those locations. Tell me what. First I can find distance to absolute darkness number 1. How do I take it? 2m minus 1 into lambda 1d divided by 2d. If you take second light, go with second light for both cases. If you take first light, do with both with first light. Understood? I'm using m's in both cases. I'm finding the distance to absolute darkness number 1. How do I do it? 2m minus 1 into lambda 1d divided by 2d. What is the first m value? First m value is given 4, right? 4, right? M value is 4. 2 into 4 minus 1 into lambda 1d divided by 2d. 2 into 4 is what? 8. 8 minus 1, 7 lambda 1d divided by 2d. That is what? Distance to absolute darkness number 1. Got it? Similar way, I can find out distance to absolute darkness 2. Distance to absolute darkness number 2. Since I used m there, I must be using m here. If you are trying with the n always. Understood? So tell me what? Second one. Again, 2m minus 1 into lambda 1d divided by 2d. What is the m second value? 11. Now, you can put it here. 2 into 11 minus 1 into lambda 1d divided by 2d. That's going to be what? 22 minus 1. 21 lambda 1d divided by 2d. This is distance to absolute darkness number 2. You are asked to find the distance between them. So this is the screen. This is the center. I got the distance to absolute darkness number 1. Okay. I got the distance to absolute darkness number 2. So how do I find this distance? This distance? This minus this, right? Correct. I'm asked to find out this distance. Distance between the first absolute darkness and second absolute darkness. Right. So I can finally take what? I can finally take these differences. Take the difference. Delta x will be what? This minus this. Right. Absolute darkness number 1, 2, bigger one is 2, minus absolute darkness number 1. What is it? That is like 21 lambda 1d by 2d minus, that will be 7 lambda 1d by 2d. So that will be like 21 minus 7, 14. 14 lambda 1d by 2d. 14 and 2 are cut 7. Substitute all the values. You will get it as, you know, if you substitute all the values, you will get delta x is equal to 28 millimeter, if I remember correctly. Right, the answer is 28 millimeters. All right, you can try this now, the calculation now. Understood? And if you do with n, you will get the same answer. But in that case, you have to use lambda 2, but you will be getting the same answer. Got this? I'll quickly revise that one more time. So distance to absolute darkness is found out how? You can use either 2m minus 1 into lambda 1 d by 2d or 2n minus 1 into lambda 2 by 2d. Okay, use either m values or n values as you wish. Okay, so I'm finding distance to absolute darkness number 1, 2m minus 1 into lambda 1 by 2d. M value, first value is 4, right? So 2 into 4 minus 1. That is 8 lambda 1 d by 2d. That is 8 minus 1, 7 lambda 1 by 2d. That is what? That is the distance to absolute darkness number 1. Look at this one. From the center, this is the screen. From the center to distance to absolute darkness number 1. Okay. Now, second location is this. Distance to absolute darkness number 2. What is it? Always from center. The distance is counted from center only. Got it? Absolute darkness number 2 is what? 2m minus 1 in lambda 1d by 2d again. What is m's second value? 11, right? You put it here, 2 into 11 minus 1 into lambda 1 by 2d. That is 22 minus 1, 21 lambda 1 d by 2d. Okay. So I got what? This distance. I got this distance. What I want is this distance. Distance between first absolute darkness and second absolute darkness. Regions of successive darknesses, right? Correct. Then what? I can find this distance how? This distance minus this distance, right? So delta x is equal to xad2 minus xad1. What is it? 21 lambda 1 d by 2d minus 7 lambda 1 d by 2d. That is 14 lambda 1 d by 2d, right? So 7 and 14 are cut. 14 and 2 are cut. You are left with 7. So finally you get 7 for this. 7 lambda 1 d by 2d. I'm trying the calculation now. Delta x is what? 7. Lambda 1 is how much? 400, right? Into 10 power minus 9. Capital D is 1 meter, right? Divided by 2 into small d is given. Oh, okay, fine, right. Sorry. 7 lambda d by d. 0.1 millimeter, right? 0.1 into 10 power minus 3. So that is what? This is 2800 into 10 power minus 9 by, this is like 10 power minus 4. Okay. 10 power minus 3 and 10 power minus 1. 10 power minus 4. This is 10 power minus 1 only. Okay. This is 10 power minus 1, 10 power minus 3, 10 power minus 4. I remember the value. That's what. And this are cut. You get 2800 into 10 power minus 5. 2 places down. 28 into 10 power minus 3 meters. 10 power minus 3 is called milli, right? So 28 millimeters. Understood this?